Today we'll be talking about managing municipal stormwater systems through GIS. My name is Sue Zitzman. I'm a GISP. I work at Mazer Consulting and manage the GIS Asset Management Services Group. We're an ESRI Silver Partner as well, so I wanted to give them a little shout out. So let's talk about stormwater overall. I'm sure most of you have heard of the Clean Water Act. It was established in 1972. It was established to prevent stormwater runoff, like discharges into our U.S. waterways. So pollutants, industrial type things, residential areas, all of those catch basins that you see that can receive water and outfalls that can discharge out into the water. So the Clean Water Act manages that. It's also known as the National Pollutant Discharge Elimination System. So NPDES, we'll refer to that throughout the presentation today. So applicants, people that carry these permits, have to adhere by the water quality standards of the NPDES. States end up developing a state standard of that permit as well, and we'll talk about those today at the municipal level. So the Stormwater Basics. So the NPDES regulates stormwater discharge. There's 3 different types of sources, people that have the permits. So it's municipal, industrial, commercial type of activities. So you want to prevent stormwater runoff. So it protects your streams, lakes, rivers, and your coastal waters. So this photograph is a good example of that. This is a rain garden behind a catch basin. And rain garden is what's known as best management practices, BMPs, for stormwater. So a lot of municipalities, which we're going to focus on today, municipalities and authorities implement BMPs, such as this rain garden, where it will capture the water before it has a chance to roll over that curb and come down into that catch basin, which eventually that water makes its way out into a stream, right? There's some kind of water source that this will end up getting to. So having your BMPs in place, helps you control that runoff. And those can be managed in GIS, which we'll talk about as well, the BMPs. Okay, so what sparked the Clean Water Act? So let's go back to the 60s, right? Cuyahoga River actually caught on fire in Cleveland, Ohio back in 1969 due to excessive runoff from industrial businesses that were along the river. So it sparked a fire. It was terrible for the environment there. A lot of wildlife and the use of the river was deemed inhabitable. So it was a big issue, and that kind of sparked this whole Clean Water Act that was evolved into 1972. And just a little side note, the Cleveland State University students protested in 1970. They came down a year after that fire down to the river and protested with it all. And that actually started the Earth Day that we have every year. I believe that's once a year, and I'm sure all of you have participated in that at some level. So now those photos at the top is what Cleveland looks like today, and they have their river otters, and people utilize that river, and there's a lot of waterfront development and use of that. So it was a good thing that this was implemented. So like I said earlier, there's 3 state pollutant discharge, SPDES, general permits. We're going to look at New York State. So I decided to pick them to just kind of spotlight some areas where their program is used. So it's industrial, construction, and municipal. And I'd like to talk about the municipal side. So if you want to learn more about this, if you Google that permit number, GPO 15003, you'll get to the New York State DEC and be able to see the details of that permit for municipal in New York. So the state permits, also known as MS4, right? Stormwater Municipal Separate Storm Sewer Systems. Say that 5 times. We're going to refer to it as MS4. It's just easier to say. It's a permit, and I want to talk about the things that relate to GIS and how GIS can help manage. So there's many components of the permit, and I'm just focusing in on the things where GIS definitely helps managing. So let's talk about the mapping requirements in New York. So they have to map their outfalls. They also have to do inspections for illicit discharge, meaning somebody's pumping into the system. Maybe they have a pipe connected to one of the outlets, like a catch basin, and they're dumping business materials into there. You know, maybe they're a painting company and they're cleaning stuff and the paint's going down into the system, and you're out there inspecting and you see this discolored water. So that's an illicit discharge. That's somebody's connecting or dumping into the system, and it needs to be mitigated. So those cases need to be inspected. You also need to map the X and Y location of your outfalls. Also in New York, the conveyance system needs to be mapped. So in order to find these illicit connections, you have to be able to track it back to the source. So you would need to have pipes and catch basins mapped as well, closed and open. So it could be a pipe. It could also be an open drainage ditch that is in between structures and eventually gets to an outfall out into a stream. So all that is best suited to be mapped and managed through GIS. And over in the left, you see the data about the end of this pipe. You see the photograph. At the pipe, we're actually recording comments that the pipe seems to be rusted out at the bottom. We list the water body that it rolls into, the type of channel that's outside of that pipe, the shape of the pipe, you know, what type of structure it is. Sometimes there's head walls or flared end sections, or it's just the end of a pipe, like in this case. So GIS enables you to track all that information and per asset, the X and Y location, and also capture the photo. You can see there's a photo link attribute there on the left. So those of you that aren't real experienced with GIS, GIS is a map, but it also has important information when you click on those mapped items to be able to see the attributes. So that's what I'm referring to on that panel that's on the left. So Cornwall-on-the-Hudson is a municipality in New York that took advantage of New York State to has a grant. It's a grants gateway for water quality improvement project. And you can receive grants, and many other states have grant opportunities as well. I find New York's to be very helpful to municipalities that need funding to help capture all this information and meet the requirements of their MS4 permit. So the grant in New York covers GIS services for GPS data collection, your reporting back to the New York State DEC. It requires a small business participation. And then their project that was done, it included 494 pipes, the conveyance system, 87 outfalls, and 485 catch basins. And you also, part of the MS4 permit in New York is you have to map the municipal facilities, so the public works headquarters and any other public buildings that the township may own. Putnam County as well use GIS to collect their outfall locations in Kent, Carmel, Southeast, Patterson, and Brewster, town of Brewster. It was a selected area that's more urban, and there was over 2,000 conveyance system pipes, 858 outfalls, and over 1,500 catch basins. So all those were visited, inspected, mapped, and photographed. So using GIS to manage your data collection and inspections, I'd like to focus on that a little bit here. So using ArcGIS Online a lot of our clients and a lot of municipalities throughout the country use ESRI ArcGIS Online, AGO. So they can make their maps, they can share that information, they can use it to analyze the data, whether there was dry weather flow in the in the outfalls, report on it. All of this is cloud-based. It's a secure and private area, and it's fairly low cost if somebody is looking to use GIS to manage their stormwater inspections responsibilities. So ESRI Web Apps and maps are used. It connects your field folks with the office and vice versa, using Survey123 for ArcGIS, Collector if you're going out for the first time and mapping your structures, and using Survey123 to perform the inspection while you're out there. And then there's a dashboard view for the person that's supervising the whole MS4 permit for a municipality. So the mobile solution helps you stay coordinated to manage the whole system, right? So you're not talking just 1 year. You need a means to be able to track multiple years and look back and track mitigation on people that are illegally connecting to your system. It's all real time, right? You can assign work to the field staff. They can go out, he or she can pick up the outfall and do the inspection on the fly, and the office staff can see that as well. It's integrated with ArcGIS software and mobile applications, and it suits the deliverables of many state agencies. So in New Jersey, the New Jersey DEP requires certain formats. In New York, the Office of DEC requires certain formats. So ESRI web applications and the reporting mechanism is very easy to configure to meet your state agency's needs. So here's some solutions. Wanted to share some of the things that we've done to help some folks along with their process of field inspections. So this is the Survey123 form that we use in New Jersey. It's 2 pages. It's fairly long. So you're able to capture the person performing the inspection, and a lot of these things that are on this form, almost all of it is required to the DEP for New Jersey. So you need to capture the type of outfall, where the outfall flows to, the type of water body, and then various other questions that the person fills out in the field using Survey123. So that form can be rolled out to all the municipalities in New Jersey, basically using the same thing. Here's the bottom part of the form. These forms are unique where if you answer yes to, is there a possible illicit connection there, that question in the middle, if you say yes, a whole nother series of questions open up. So the form gets even longer. You know, what color is the water that you're seeing during dry weather flow? Is there an odor? You know, is there a sheen? Things of that nature, additional questions that come up when you answer yes. So somebody may pose the question, how long, what's considered dry weather flow? 72 hours, at least in New Jersey. I believe New York is the same. So you would not have a rain event, or if there was snow on the ground and it's melting, there would be no natural cause of water running through that outfall. So 72 hours usually is the time frame we have to wait before we can go out and do inspections. So the form also has a nice map at the bottom. You can see where you're at. That's useful if you've already collected everything the year before and you're going back out to revisit. You can, with these applications from ESRI, these web apps, it can navigate you to your location. You know, a lot of times summer interns are doing some of these inspections, and you can just hand them this application, they'll see the map, click on the point, and it'll navigate them to it so they can perform their inspection. And then way at the bottom, you can see you have the option to take a picture of the outfall. So what is our workflow? So I wanted to share this with you. So for an inspection for stormwater outfalls, and this also goes for catch basin inspections, you want to develop the form that have the proper questions as we just looked at. That gets published out to your ArcGIS Online account. The folks performing the work in the field would open Survey123 from their mobile device. They'll navigate to the asset like I just explained. They'll perform the inspection. They save that form, and that data is saved automatically back to the AGO. So the benefits of going mobile, I think you probably saw a lot of them on there. So you're standardizing the data collection. So we typically use ESRI's local government model, and then we modify it to meet the MS4 permit for that state. It's recorded once. You eliminate the need for data entry in the office. So if Sally or Sam are out in the field, they collect their inspection information on a piece of paper, you come back and somebody has to enter that. You remove that whole process. So it's all done right in the field. It's streamlined. So access associated documents and data in the field, creating those conditional logic-based forms. Again, that's the part where you answer yes to elicit connection, and then a whole bunch of other questions come up. You reduce the possibility of lost information. So your intern, not to get on interns, but they're out there and they drop the iPad in the stream. It's happened, or drop it down the catch basin. The data has been collected in the forms, so you're not going to lose anything except for the inspection they were in the middle of doing. So you have to save the document at the end of each inspection, so that's automatically pushed back. So worst case scenario, the intern doesn't work for you anymore, the iPad's ruined, and you lost the one inspection they were in the middle of doing. So you also cut down on physical storage demand. A lot of this stuff's out in the cloud. You're just pushing data out to the cloud. It's all real time. The office and the field see it. And the most important thing, it's environmentally friendly, since we were talking about Earth Day. So training's a very important component of any type of system that you're implementing with GIS. You need to train the staff that are using it, field and office. They have different roles. Office typically is running the reports against all the data to supply it back to the agency requiring your MS4 permit information, and the field staff need to be trained in order how to do the inspections and the data collection properly. So typically we're creating SOPs, standard operating procedures. They can easily be handed to new employees along with a training manual that explains everything in detail about how to get the app on your device, how to do a whole inspection, how to go out and GPS data collect an outfall. Maybe you don't have any mapping started. It's your first year. You would use ESRI collector for ArcGIS to collect those outfall points and then to do the inspection. So you'd have that all documented very easily to pass along to your new staff. So maintenance and support is also important. So you have people maintaining the inspections and the location of the outfalls, but you need to maintain the other data that surrounds that. So if you have road maps, supportive base maps that are on your web applications through web maps, you want to have the right parceling, the road center lines, some surface data, surface features. You want to keep those updated in the map that is used for your inspections. Also, your annual reporting. You want to be able to run those every year. We've had instances, I won't say who they were, but we've had instances where the MS4 permit was put in place. There was a lot of panic. Oh my God, we got to get this done. And got all the inspections using GIS and all set up. But then the following years, they went back to their handwritten reports and let the data go by the wayside and, ended up trying to re-implement it again just because there wasn't any focus or the maintenance and support of what they invested in. So if you're going to roll in this direction with GIS and do your MS4 permitting through that on the GIS components, you definitely want to maintain it. And the system can be expanded. So I've got a couple more slides. There's like 2 or 3 talking about how it could be expanded and used in other aspects of asset management for stormwater management in GIS. So O&M of the BMPs that we talked about earlier. I'm using a lot of acronyms, but there are a lot in the MS4 world, stormwater. So the best management practice were things like bioswales. We looked at a rain garden in the beginning of the presentation. There's also certain types of pavements that can receive water. You have your retention and detention basins, rain barrel program, being able to track all that information. GIS is great for that. So, maybe easements or detention basins that need to be mowed or fences need to be maintained around them. Why not use GIS to manage the work processes that happen behind the scenes for all of these BMPs? So it's a really good way to map all of these other components and put in your maintenance, your work orders and things through the ESRI applications as well. And then the GIS use for stormwater fee. A lot of people don't like to talk about this, but in Pennsylvania, there is a stormwater fee in place at a lot of the cities. And we worked with a couple of the cities in Pennsylvania to use GIS to calculate the impervious coverages. So I know we talked a little bit about New Jersey as well. In New Jersey, they're just starting to possibly look at stormwater fees, implementing those, whether it's an authority or a municipality. So where we've used GIS for that to help our city clients throughout the nation is calculating the impervious areas. So yellow is the person's parcel, and then the open polygons are the structures, and then the filled in areas are required areas that should be calculated for impervious. So sidewalks that are a certain width, it could be a parking lot, anything that cannot push water through, impervious, right? That's what that means. So the stormwater has to run off of that. So a lot of the cities are looking to generate fees. So if you use GIS, you get the square footage per property. And in this particular city, it was 1,000 to 2,000 types of residential properties just generally chosen throughout the town. And then there was also industrial, commercial properties that were taken. So an average is going to be taken and generate a fee per square foot per type of use. So it's pretty involved, but you can just imagine trying to do this without GIS could be pretty daunting task. So that's something that we're seeing move up. We get a lot of these requests doing this type of work. And there is some machine learning applications you can do. I haven't been super thrilled with them. They're not very high percentage of accuracy, but it definitely can cut down on some of the legwork where you're using GIS, where it looks at detailed imagery and is able to look at certain pixelated information and consider it as impervious coverage, and it automates the process a little bit. But I think that still needs some work on to get to that point where there's less human interaction with it. So let's summarize this, and then we'll switch it over to Maria, and she'll start reading off some of your questions that you have, and hopefully I can answer them. So in summary, maintaining your stormwater with the GIS program gives you a reliable source for all of your current conditions in the field for your MS4. Implementing the whole mobile side of it really streamlines your daily process of your O&M, even dealing with all of those best management practices as well. It's all real time, office in the field, everybody's looking at the same thing 24/7. It really empowers the staff, the office in the field to collaborate together, and it's definitely has saved our clients time, definitely. It's proven, right? We've been doing this for a long time. It's time and cost savings. Managers can utilize all their resources efficiently as well. So proven results using GIS for MS4. So there's my contact information. That's my cell number. You're welcome to give me a buzz and my email address, and I'm going to switch it over to Maria for answering some questions.
Hi, thank you very much, Sue. We do have a few questions here. The first question is from Sean. What equipment do you use in the field to perform the data collection and inspections?
Sure. So there's a lot of different things out there that you can use with GPS and the mobile devices. So we typically implement using iPads in the field, coupled with either EOS Gold or Trimble units. So tying that together gives you a little bit more accuracy, and the ESRI platform works really well on the iOS. It also works on some of the other ones as well, but that's what we typically see.
Okay, thank you. A question from Beth. What are accuracy requirements of outfall and catch basin data collection?
So some of the states do put an accuracy level in there. So typically we see horizontal accuracies being sub-meter. Not usually any kind of vertical, not inverts and things of that nature, any kind of accuracies, but most of the MS4 permitting mapping requires a horizontal sub-meter.
Okay, thank you. One more question here. This is from John. How long does it take to get someone up and running with the field process?
So the field process is fairly easy. Once you have your form set up, you're literally spending maybe a couple hours shadowing the folks that are going to be in the field to collect the information. And on the reporting side, again, it's a couple hours of your supervisors or the managers of the MS4 program being able to get the reporting out that they need to submit to their agencies.
Okay, that should wrap it up with the questions, Sue. So any last remarks or comments?
No, I hope this was of value to everyone, and I really thank you for tuning in and listening to our seminar today, and look forward to doing another one. So keep your eyes peeled for our next webinar.